Hey everyone, welcome back to our channel. Now today's video is about one of the important concepts when it comes to deep learning, that is bias in deep learning neural network. Now why this is important, but before we go over there about learning about bias, let's first understand what exactly is this bias would mean. So theoretically, when I say bias is something which will allow the neural network to better fit the data. So by definition, it is going to allow us to better fit the data. Now this is the common definition that you will be coming across in various blogs as well. But what exactly is this concept and what is the intuition behind it? Now to understand this, let's take up an example. Let's jump into our OneNote book. Alright, now being in my OneNote, let's take up an example. The example that we are going to take is, let's say a simple neuron. This is a single neuron. Okay, this is a single neuron and it takes one input. It is going to process this input and I'm going to give an output as y. I'll say x is my input. This input will get processed over here in this neuron and the output will be generated. Now for the understanding purpose and to keep it very simple, I'm going to say no activation. There is no activation function for this neuron. Alright. Output would be simple as y is equal to w into x plus b. So w is a weight with reference for my input x, and x is my input and b is my bias term, which is what we will be seeing in every neural network. Now let's understand the importance of this term, that is the hero of our video, that is bias term. Okay, so this is our bias term. Now for the sake of simplicity, let's take up a very simple problem. Goes like this. Okay, so I have some collection of points. So these are the collection of points that I have with me. So the points are having the coordinates as 1, 5, this is 2, 7, this is 3, 9 and this is 4, 11. So these are the 4 data points that we have over here, which clearly says this, like if I give 1 as an input, I'll be getting the output as 5. If I give 2 as an input, I'll be getting the output as 7. So in that manner, I'm going to interpret these 2 pair of points. Alright, now let's do one thing. Now the way that we are going to learn the importance of this bias in a neural network is, first, we are going to use the same model, that is a single neuron that we have just chosen. We'll use that same single neuron and we'll try to fit this data points that we have without bias term. And when we do that, what are the disadvantages and what is the challenge that we are facing over there? And from there, we are going to understand the importance of bias term. Alright, so the data points, let me just take a screenshot of this and we can use it in our notebook. So this is the collection of data points that we have over here. Okay, now being in this notebook. So this is my data points. My A is 1, 5, B is 2, 7, C is 3, 9, D is 4, 11. So these are the 4 different data points that I'm having over here. Now let's take up a scenario where I do not have a bias term. So if I do not have a bias term, the equation that I'm looking at is y is equal to wx. The reason because, as I mentioned already, this is a single neuron and without the bias term, this will be same as y is equal to w into x. Now w is the weight for my input x. Now let's look at the possible set of values for w. Alright, so since it's very simple, let's choose the points. So I'll take 1 and 5 and 2 and 7 for the testing purpose. Now when x is equal to 2 and I'm expecting my y to be equal to 7. So what are the various values of w that I should be using in order to make sure that this condition is satisfied? So in this example, I can say that my w should be 3.5. And in this scenario, my w should be 5. And if I take the next scenario, 3 and 9, then my w is expecting to be 3. Obviously, I can clearly see that there is no single value of w which is helping me to fit all the data points. Now to give you an intuition, let's do one thing. I'm going to draw a line. I'll say y is equal to 2x, y is equal to 3x, y is equal to 3.5x, which is what we have seen for one of these scenario, y is equal to 4x, and just observe what is happening over here. Now I have created the lines. I have created multiple lines, and you can clearly see that with y is equal to wx format, all the lines are passing through the origin. Now I'll give one more line. Let's say y is equal to minus 5x. Observe, even this line is passing through the origin. But a real scenario or a right scenario is I want to have a data point which passes through all the data points, and that is a line equation which I'm trying to find out in order to fit these data points. But in this scenario, I can clearly see that all the data points are passing through the origin. I'll say y is equal to 6x. See, all the data points are passing through the origin. Okay, so one disadvantage that I'm seeing over here is without the bias term, every equation line will pass through the origin. If those data representation line does not pass through the origin, I may not be able to learn in an efficient manner. Now, let's see the magic. What would happen if I include the bias term? I'll do one thing. We'll come over here to the solution. So if you look at it with the bias term, so the correct line equation is y is equal to 2x plus 3. Now with the bias term, we can clearly see that I have a line which passes through all the data points. Okay, now coming back to our slide, the definition about bias. So bias is a value which will allow the neural network to better fit the data, and we could observe the same over here as well. So with the bias term, I'm able to draw a line which passes away from my origin, but making sure that it passes through my data points. So that means this is giving me the freedom to allow my neural network to better fit the data. I'm not constrained to find the line equation which passes through the origin. At least I'm able to find the line equation which passes through anywhere in the plane. So that's the advantage of bias in neural network. Now coming back over here. So in our example, I have considered this example, which is a single neuron with just single input. Now this can be generalized to any number of neurons with any number of inputs. Now you might have a question as, okay, so in this scenario there is no activation function, but if I have an activation function, does it still plays an important role? Yes, obviously it plays an important role. See, activation function I'll be applying on top of my linear operation. So the first part is linear operation, where I'm going to take the dot product between my inputs as well as my weights. And in the second part, I'm applying my activation function. So this activation function will be applied on top of this linear operation. This taking the dot product and adding the bias term. Now, if I have the restriction in the first step itself, that is, if I have the restriction on my model to just find the model which passes through the origin, obviously even my activation function will not be able to learn better with the data that we have. So in order to enable the neural network to better fit the data, we make use of this bias term in neural network, and that's the importance of bias term in neural network. And even when you're working with machine learning model, you might have seen a term that's called as W0 or some other term, but the first term that you would see over there in the linear regression model, that's also a bias term. So whatever the things that you have seen in machine learning, which holds good for this single neuron or multiple neurons without activation function. I'm talking about equation perspective. You can think as linear regression plus activation is what your equation for a single neuron output. Okay, I hope you find this video useful. I hope you now understood the importance of bias in neural network. If you have any questions and queries, do let us know in the comment section. I'll be happy to help you. Thank you so much for watching. I look forward to seeing you next time. Take care.